Welcome to Luvitex Engineering, where we sketch out the things that keep the industrial world moving. Now, let's start.
All around us, there are these powerful forces at work, usually totally hidden from sight. So today, we're going to pull back the curtain on one of the most ingenious of these hidden giants. A simple screw that has the power to lift elevators and even fine-tune musical instruments. It's called the worm gear. Okay, let's just jump right in with the question. Think about an elevator, an automatic gate at a parking garage, and the little tuning pegs on a guitar. I mean, what on earth could those three things possibly have in common? It sounds like a trick question, right? But they all depend on the exact same really elegant piece of engineering. And yep, the answer is the worm gear. This simple but honestly brilliant mechanism is pretty much just a screw that meshes with a gear to transmit motion. And in a lot of ways, it's what helps turn our modern world. So let's break down exactly how it works. So at its most basic level, a worm drive has just two parts. You've got the worm, which is really just a thread screw, and the worm wheel, which looks kind of like a standard gear. The real magic happens right where they meet. As that worm turns, its threads just smoothly slide into the teeth of the wheel, transmitting power and, this is the really key part, it changes the direction of rotation by a perfect 90 degrees. It's just a super simple, elegant fix for a very common engineering challenge. Okay, so you're probably wondering, how is this different from the gears you'd see on, say, a bicycle? Well, most gears, like spur gears, work with rolling contact. Their teeth mesh and push each other, which is really, really efficient. But a worm gear, it's totally different. It relies on sliding contact. The screw thread literally slides across the face of the gear teeth. Now that motion creates a lot more friction and heat. But, as you're about to see, that friction is the source of its most incredible superpowers. Right, so this whole sliding action, it creates this kind of unique mechanical dance between raw power and incredible precision. Let's take a look at what makes it so special, starting with its amazing ability to mess with speed and torque. One of the worm gear's biggest claims to fame is massive speed reduction. To get a gear ratio of 100:1, like you see here, it means the worm has to spin 100 times just to get the wheel to turn once. Now, to do that with normal gears, you'd need a huge, clunky, complicated gearbox. The worm gear, it does it all in one compact, elegant step. And by slowing down the speed that much, it multiplies the torque like crazy. Think of it like using a super long wrench to turn a really stubborn bolt. That's the kind of power boost we're talking about, all packed into a tiny space. And you know, this design wasn't perfect from day one. It's gotten better over time. The most basic version is called non-throated, where the worm and wheel just touch at a single point. Not very strong, wears out fast. Then engineers came up with single-throated, where the wheel's teeth are curved. This creates a whole line of contact, which is way better. But the ultimate design is the double-throated. Here, both the worm and the wheel are curved to wrap around each other, which gives you the maximum possible contact area for just insane torque capacity. But look, the most incredible, the most defining thing about the worm gear, its real superpower, is something called self-locking. And here's the twist. It's both its greatest strength and its biggest weakness. To really get this, just imagine for a second. You're in an elevator, or maybe you see a hoist lifting something heavy, and suddenly the power cuts out. What stops everything from just plummeting to the ground? It's not just a brake. Well, that's the self-locking in action. See, in most worm gear setups, the motor can turn the worm to move the wheel, but you can't turn the wheel to move the worm. The system is a one-way street. So if the power dies, the weight of the load on the wheel can't backdrive the motor. The whole thing just stays put, locked in place by nothing more than friction. So how does it do that? What's the secret sauce here? Well, it all comes down to the angle of the worm's thread. When that angle is really, really shallow, we're talking typically less than 5 degrees, the force of friction actually becomes more powerful than the force of the load trying to push it backward. The wheel is trying to push the screw, but the angle is so gentle that it just wedges itself in place. It's amazing. But there's always a trade-off, right? That same incredible friction that gives you all that safety, well, it's also a massive energy thief. Because so much energy is just lost as heat, the efficiency of a self-locking worm drive is often less than 50%. So yeah, you get this amazing safety and load-holding capability, but you have to sacrifice efficiency and deal with a whole lot of extra heat. Okay, but all that friction and all that heat means that worm gears can be, well, a little bit vulnerable. When they do fail, it's usually for one of a handful of key reasons. We can think of them as the 7 deadly sins of worm gear failure. Yeah, there are 7 big ones. Things like overheating, contamination, just excessive wear. But one of them, oh boy, one of them is the main villain, responsible for almost half of all the problems. And drumroll please, here it is. The #1 killer of worm gears is improper lubrication. It accounts for a staggering 45% of all failures. Think about it, with all that sliding contact we talked about, lubrication isn't just a nice to have, it's literally the lifeblood of the entire system. And it almost always comes down to one of 3 really simple mistakes. First, just running the system with too little lubricant. Second, using the wrong kind of lubricant, like some generic oil, instead of one designed for extreme pressure. And third, just not having enough in there to maintain that vital protective film between the 2 sliding surfaces. Okay, so that's the bad news, but the good news? All of this is super preventable. So how do you keep that worm turning reliably? It all comes down to a few key best practices. All right, first things first, to beat that #1 problem, lubrication, you gotta have the right oil. That means a high viscosity oil, something that's thick and really clings to the gears. And it absolutely must have what are called extreme pressure or EP additives. Those are special ingredients specifically designed to protect against that intense sliding friction. After that, it's easy. Check the oil level every day and just follow the manufacturer's schedule for oil changes, just like you would for your car. And what about those other big issues like wear and overheating? Well, the rules are just as simple. Don't overload the system. Make sure the gears are perfectly aligned when you install them, and keep any cooling fins clean so they can actually do their job. A healthy worm gear likes to run between 160 and 180 degrees Fahrenheit. If you see it getting over 200, that's a sign of trouble. You know, at the end of the day, it all boils down to this one simple idea. A small investment in prevention today can save you from huge costs and a ton of downtime tomorrow. A little bit of attention makes sure these hidden giants can keep doing their job for years and years. So there you have it. You're officially in on the secret of the worm gear. The next time you step into an elevator, see a conveyor belt moving, or even just tune a guitar, you'll know about the magic that's happening behind the scenes. The only question left is, where are you gonna spot this tiny titan of torque next?
Thanks for watching. For more industrial insights, check out our other videos. Don't forget to like, share, and subscribe to Luvitex Engineering.